So another method of integration, instead of using integration by parts, is called the tabular method. And this method can be really helpful when you have to complete integration by parts many times. It just makes things a little bit simpler. And the only thing is, this method can only be used when you have a trig function, an exponential function, or an algebraic function inside of the integral. And you can use the acronym T, so you know which functions are allowed to go inside of the integral when you're using the tabular method. So let's try an example. So we have the integral of x squared times e to the x with respect to x. So the function that we're going to be taking the derivative of is x squared, so you can just write x squared in the table, and then we're going to take the integral of e to the x. So now we just go down the table and we take the derivative of x squared and then the integral of e to the x until the derivative of x squared is equal to 0. So we can take 2x and then 2, and then the derivative of 2 is 0. And then the integral of e to the x is just e to the x. So we can just write that for all of the rows. And then in the sign column, we just have to alternate the plus and minus signs. So we have plus, and minus. So now to complete the integral and find the answer, we can match up the columns. So we have x squared and e to the x, 2x and e to the x, and then 2 and e to the x. So now we're just going to multiply our sign times the products that we just made. So we have the positive sign times x squared times e to the x. So we have x squared times e to the x. And now we're going to subtract 2x times e to the x. So minus 2x times e to the x. And then the third row of the column, we have a plus sign, 2, and then e to the x. So we have plus 2 e to the x. And then the fourth row, we would take the integral of whatever is inside of the multiplication of e to the x times 0, and then we'd subtract that. But in this case, since we're multiplying a 0 times e to the x, the integral would just be 0, so we don't have to write that out. And then we can just add plus c. And then this is our final answer. And it's much simpler than doing integration by parts like many times.